Assalamualaikum warahmatullahi wabarakatuh. So this is part 3 or part C. Example 3.1 Truss analysis using stiffness method. Okay, we are going to analyze this truss. Okay, this truss has 4 nodes. Node number 1, 2, 3, and 4. Which has 3 elements: element 1, element 2, and element 3. So since there are 4 nodes, there are in total 8 degree of freedom. There are in total 8 degree of freedom, and there are in the diagram the arrow as well, and degree of freedom label from 1 to 8, where we label degree of freedom according to unconstrained and constrained system. So there are 8 degree of freedom, where we divide into 2 systems, unconstrained and constrained system, where in constrained system there are 6 QU, representing 6 unknown reaction, and under unconstrained there are 2 DU, unknown displacement. So total equivalent to 8. So there are 2 degree of freedom for unconstrained system, representing by 1 and 2. 1 and 2 representing unconstrained system. And there are 6 degree of freedom which come from reaction, which come from pin, because pin is constrained, pin is support. So there are 3 pin support. 3 pin support means there are 6 degree of freedom, 6 unknown reaction. So in total there are 8 degree of freedom. So 1 and 2, okay, unconstrained system, no support. And then 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Okay, 7, 8 belong to constrained system. Okay, so we need to label according to unconstrained followed by constrained, because between unknown displacement du, between unknown displacement and unknown reaction, we determine unknown displacement first. We will determine unknown displacement first, then only we can determine unknown reaction. That is why we need to label 1 and 2 first, followed by constraint system. Okay, so beside these 4 important things inside the diagram, node number, element number, arrow. Arrow is very, very important. We need to have the arrow which is parallel. The truss has the element must have arrow which is parallel to the member, because from the arrow we can be able to identify near and far end nodes. And then since we are referring to the coordinate system, so we have to have coordinate inside the truss. We have to have coordinate inside truss. Okay, so we have to label the coordinate. So we choose one as origin, and we have to label the remaining. This is 0, 3, this is 0, 7, and this is 4, 3 coordinate. So where we need to use this coordinate, whenever we determine lambda x and lambda y. So lambda x and lambda y in different books may be used by the CX, CY symbol. So this is actually I took from the textbook. So textbook use lambda x and lambda y. So K, okay, this K represent the structure, the element, not the structure, the element stiffness matrix. This is element. Small k, this is element stiffness matrix. element stiffness matrix. Means that we have to use this formula for each element to calculate or to form or to produce the element stiffness matrix. Okay, so we go one by one step. Actually, I have covered this example before this under part A and part B. Under part A, I have actually explained about the concept, about five criteria, five important things that need to be fulfilled in the diagram. I have also determined about explained about this, about 8 degree of freedom, about Q unknown displacement, about unknown reaction, about force displacement equation. Okay, I have determined, I have explained all this, okay, in part A video, and then followed by part B video. In part B, I have actually covers two, okay, how we establish element stiffness matrices and establish structure stiffness matrix for the truss. Okay, now we are going to move to the third part of analysis, okay, where after we have established structure stiffness matrix, we will use the stiffness matrix in order to determine the unknown. The first unknown we need to determine, okay, is displacement, and then reaction at the support, and then reaction at the support. Okay, so let's go through the question first again. The question again. Okay, number one, establish element stiffness matrices. Establish element stiffness matrices K1, K2, and K3. Since there are three elements in the truss, so we need to establish element stiffness matrices K1, K2, and K3 in the global coordinate system. We are referring to the global coordinate system formula. Okay, the K I just have shown to you just now. Okay, after that, when we combine the element stiffness matrices, when we combine, we produce the structure stiffness matrix, capital K. The structure stiffness matrix, capital K. Okay, and then we need to establish, after that, we need to establish what we call as force displacement equation. It is force displacement equation. Force displacement equation. And we need to write all these equation, okay, by in matrix form. In matrix form means that we have to write Q in terms of matrix. We call it as nodal displacement and nodal forces. Nodal forces. We have to write unknown. We have to write displacement in matrix form as well, called as nodal displacement. Nodal displacement, and K we get from the previous step. It is structure stiffness matrix. Structure stiffness matrix. This is structure stiffness matrix. Okay, so now, okay, we have gone through step okay, element number one. Okay, we have established the K1. So this is K1. Okay, K1. So we okay, we simplify until we get this AE constant. AE constant, and the most important thing is the label. So this label is very important. This label is very important because this is the position, the degree of freedom position. Okay, so how we get this label? By looking back to the diagram. So this is element number one, and look at the arrow. Look at the arrow. So we will label from near to far. Near is located. Okay, near is located. Near is one. Two is far, because the arrow is always move towards far end. So this will be far. This will be near. So when we label the K, we will label as 1, 2, 3, 4 for element number one. Okay, same goes to element number two. Element number two, by looking at the arrow, 3 will be far. So the label for K will be 1, 2, 1, 2, 5, 6. And then same also goes to element number three. The arrow move towards far end. So node number 4 will be far. So the label for degree of freedom for K will be 1, 2, 7, 8. Okay, so we use the formula. So we use the formula to determine delta X and delta Y. So delta X and delta Y, I have actually explained it in the previous video, part B. So please look at the video, watch the video. Okay, so the most important thing, so for this step, we will establish K1 in terms of AE, and then K2 in terms of AE. Okay, and the label for K2 will be 1, 2, 5, 6, as I mentioned just now. And then we go to element number 3. Element number 3, again, we use the formula for lambda X and lambda Y. And we use the formula to calculate element stiffness matrix. And we get this matrix, 4 by 4 matrix. And the label will be 1, 2, 7, 8. Okay, 1, 2, 7, 8, because we label start from near end to far end, and each end has 2 degree of freedom. Okay, and then what we need to do is we have to combine K1 plus K2 plus K3, K1 plus K2 plus K3, and because K, the structure stiffness matrix, has 8 degree of freedom, means that we have to produce 8 by 8 matrix. 8 by 8 matrix for the structure stiffness matrix, and this 8 by 8 matrix will be written in order. In order means from 1 to 8 position, So what we need to do is we have to find the value from K1, K2, and K3 and produce this. Find the value from K1, K2, and K3, and then we have this. For example, if I want to determine the value at position 1, 1, 1, 1 means that I have to consider 1, 1 here plus 1, 1 here plus 1, 1 here. So in total these three value, so we get 0.466. Okay, another example. I want to find the value for 5, 6. So I want to have the value for 5, 6. Okay, 5, 6. So in K3, no 5, 6. In K2, no. In K2, 5, 6. 5, 6 is equal to 0, and there is no 5, 6 in K1. So the answer will be 0. Okay, another example. I want to find the value at position 7, 8. At position 7, 8, this is position 7, 8, 0.096. So how we get this 0.096? Okay, we refer to K3, 7, 7, 8. 7, 8 is here, 0.096. 7, 8 in K2, no. 7, 8 in K1, no as well. So we get only 0.096. So we do the same for all positions. So we get like this. This is the structure stiffness matrix. Okay, now we want to continue. To write the stiffness equation. Or the force force displacement equation, right? Right force displacement equation. Okay, what we want to write now is the stiffness equation. Okay, it is stiffness equation or force displacement equation. Force displacement equation, or this is also called as stiffness equation. So what is the equation? It is Q is equal to KD. It is Q equal to KD. It is Q equal to K D. It is Q equal to K D. And remember this one we have to write in matrix form. We have to write in matrix form. Means that Q nodal force will have Q1 until Q8 because there are 8 degrees of freedom. And D as well, we have D1 until D8 because there are 8 degrees of freedom. So there are Q1, Q2, Q3, Q4, Q5, Q6, Q8, and we have D1, D2, D3, D4, D5, D6, D7, and D8. And K, we have this. Okay? And this. Okay, so we have Q. We have Q. Okay, it is. Okay, equal to this. This is how we write the equation. This is D. In matrix form. In matrix form. Okay, in matrix form. Okay, so we have Q1, Q2, Q1 and Q2, and we have back to this, we will have 6 degree 6 QU means 6 unknown reaction. 6 unknown reaction means we have to list Q3 until Q8 with symbol only, because Q3 until Q8 will be the output later. Okay, so what we need to put into the nodal forces, okay, the value, okay, we need to consider at position 1 and at position 2. Representing unconstrained system, we have to put the forces value in one, okay, in X direction and in Y direction, X and Y component. Okay, because inside this, what we have is, always remember that degree of freedom, we have to always look at that into forces and displacement. Means that Q, okay, we have to have 8Q. Okay, so we have to know Q1 represent what, Q2 represent what, Q3 represent what, until Q8. Same goes to D. D1, what is D1? D1 is unknown displacement at position 1 in X direction, in X component. What is the meaning of D2? D2 is displacement at position number 1 in Y component, Y direction. That is D1 and D2. So what is the value for D3, D4, D5 until D8? D3 until D8, since it all displacement located in at the support. So displacement will be 0. So we have to be able to read the information from the diagram. So we have to write Q1 until Q8, D1 until D8, but in matrix form. So let's say we should have like this actually. This is Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8. Okay, there are 8Q. Q3 until Q8 are the reaction at the support. If we look at the diagram. Okay. Okay, if we look at this diagram, there are 8 positions, 1 until 8, in terms of Q. 3, 3, 4. What does it means? 3 means, Q3 means reaction force. Reaction at position 2. Position 2 in X direction. In X direction. What is the meaning of Q3? Reaction at position 2 in Y direction. Q5. Reaction at position 3. Reaction at position 3 in X direction. Q6. Reaction at position 3 in Y direction. Okay. So all this due to pin support, there are 3 pin support. 3 pin support means 6 unknown reaction. 6 unknown reaction label as Q3 until Q8. So we should remain the symbol Q3 until Q8 in the equation. Q3 until Q8. Q3 until Q8. Here. Q3 until Q8. So, what is the meaning of Q1 and Q2? What is the meaning of Q1 and Q2? Q1 is actually horizontal force at node 1. Horizontal force at node 1. What is the meaning of Q2? It is a vertical force at node 1. Okay, so what is the value? So please look at back to the diagram. At position 1, there is no Q1. It is equal to 0. What about Q2? Q2, this is 2. It is a vertical force. So it will be equal to negative 20 because it is opposite with sign convention. Of course, this will be the sign convention. Okay, so the value that we should put into the matrix for the nodal force, okay, nodal forces 1 until 8 will be 0 and negative 20. 0, this will be 0 and negative 20. 0 and negative 20. To 1, 2, 3, 4, 5, 6, 7. 3, 4. Okay. Only 7. So wait. 3, 4, 5, 6. Q6. Q4. Q5. Q6. Q7. Q8. You want to have matrix? Three, 4, 5, 6, 7, 8. Okay, doesn't matter. So into maths. So this is the nodal force, and we will adjust this. This is 4, 5, 6, 7. We get this as 7. Okay. Okay, so this will be the nodal force. Nodal forces. Okay, nodal forces Q actually like this. Okay, we continue, and then we put K here. So this is K value. I just copy this and put inside this. Okay, so this is Q, K, and D. So what about D? So I copy this first because I want to copy the format. So this will be D1 and D2. Because D1 and D2 will be the unknown displacement. Okay, this will be D1 and D2. This is 1. This is D. This will be D1 and D2. Okay, this will be D2. And then at position 3 until position 8, because it is actually represent displacement at support, so there is no value because displacement at support equal to 0. Displacement at support equal to 0 unless there is a support settlement. Okay, so this will be the equation. This is the force displacement equation. Okay, 8 position. This will be 8 representing position 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 position. 1, 2, 3, 4, 5, 6, 7, 8. 8 position. So this is called as stiffness equation. And inside this, actually we can draw the boundary. Okay, between unconstrained and constrained system. Because constrained, okay, unconstrained 1 and 2, constrained 3, 4, 5, 6, 7, 8. Okay. So this will be unconstrained, constrained. And actually, whenever we want to calculate unknown displacement, due to the zero displacement, there are 6 zero displacement at position 3 until position 8. So the one that we analyze to get D1 and D2 will only be the unconstrained system. Because for position 3 until position 8, when we times with displacement 0, when we times with 0, we get 0. So it is just like we analyze only unconstrained system. Okay, so actually to solve for the unknown displacement, we are analyzing to solve solve unknown displacement. Displacement at position 1 and 2. Okay, what we should do is we just analyze equation, stiffness equation corresponding. We analyze stiffness equation corresponding to unconstrained degree of freedom. To solve unknown displacement at position 1 and 2, we analyze stiffness equation corresponding to unconstrained degree of freedom. So we can write equation as this. So we have 0 and negative 20 equal to AE. So it is 0.466, 0.466, and we get 0.872, 0.872, and we have 0.16, 0.16, close bracket, times with D1 and D2. Times D1 and D2. Okay, doesn't matter. We just need to take the format. So we adjust back. It is 0 and negative 20. 0 and negative 20. This is AE. This is negative 20. 0.872. 0.872. 0.16. And we get D1 and D2. We get D1 and D2. Here. Get D1 and D2. This is D1. And D2. Okay, so this is the equation. This is the equation. So when we solve this, we will get D1 and D2. If AE is given, then substitute AE now. If not, we will get D1 and D2 in terms of AE. D1 and D2 in terms of AE. So how we solve this? We just solve this using simultaneous equation. It's just like two simultaneous equation. Just like two simultaneous equation. And we can calculate easily using calculator as usual. Okay, so we will get D1 and D2 value. Okay, so we get D1 and D2, which is equal to 1 over AE, and we get the value. This is D1 and D2. Unknown displacement at position 1 at position 2. Okay, we just need to calculate by substituting value A1, A1, B1, C1. This is A1, this is B1, this is C1, C1. A1, B1, and then this is A2, B2, C2. So substitute this into calculator and then we will get these two values. The displacement at position 1 and at position 2. Okay? Okay, so this is part C of analysis. Part C of analysis. So we have discussed until we have discussed 1, 2, 3, and 4. So I will stop this video up to this level where I have shown to you how we actually solve the unknown displacement. Okay, the unknown displacement, and in the next video I will show to you how we calculate reaction at the support as well as member forces. Okay, actually using multiplication only by using the equation, we substitute the value of D1 and D2 into stiffness equation in full, okay, in 8 by 8 matrix. Then we will calculate reaction at the support Q3 until Q8, and then using the displacement as well, we can calculate member forces. Okay, so that's all for part 3. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.